So yeah, my name is Ben Visness. For my actual work, I'm a WebAssembly engineer at Mozilla. I'm the lead of the Handmade Online community. And so given that kind of background, and given what this conference is about, you might be surprised by the title of my talk, right? Like, if you're looking at that on the schedule before you got here, you might have been sort of surprised, skeptical. Like, you probably think of Handmade as a low-level thing, generally, right? Because, like, Handmade Seattle grew out of Handmade Hero, and Handmade Hero is a series where you learn to make a game engine, without using libraries, without using other third-party engines, right? You're learning how to make all of that stuff yourself. That's a low-level kind of idea, right? And then fans of Handmade Hero took that attitude into other projects and other domains and started learning how to make stuff, other things from scratch. So Handmade's clearly about low level, right? And we also talk within the Handmade community a lot about the software industry and the problems of the software industry. The ways that software is developed getting worse, like software getting huge, getting slow, getting bloated. How our computers today that are orders of magnitude more powerful feel slower to use than the computers that we had a decade or two ago. And we seem to think that low level is somehow the way to fix these problems. But like, why? Do we really, like, if we imagine a better future for the software industry, do we imagine a future where everybody is hand-rolling all of their own UIs and making their own text editors and their own programming languages and never using any libraries at all? Like, is that actually the future we envision? How does that even make any sense? So I do think that low-level programming is the path to a better future for the software industry, but also, my talk is called High Level is the Goal. So what's the connection here? Why do we actually care about low level so much? So to start things off, I want to show you a cool project. This is Truckla. This is a project from 2019 by a YouTuber named Simone Yetch. This was before the Cybertruck was announced, and she wanted an electric pickup truck. And so she and several collaborators decided, okay, we'll just take a Tesla Model 3 and turn it into a pickup truck. And this is the result. I think it's incredibly well done. Like, it's a surprisingly good-looking result. It actually works. It can haul stuff around. And to do this kind of thing actually takes a ton of legitimate intelligence and creativity, real engineering to make this work, right? You can't just cut the roof off a sedan and call it a pickup truck. You have to actually make sure it's structurally sound still. And you have to make sure that it can still charge and drive, that you didn't like break the control system by cutting out important stuff. You need to know a ton about the car and the mechanics of cars in order to make this thing work. It's really pretty impressive. But also, it's still not really a good pickup truck, right? Like, if you actually were in the market for a pickup truck and you were comparing models, you would not pick Truckla. A run-of-the-mill F-150 or something like that is going to be better at pickup truck things than Truckla is. And it's not because they did a bad job with Truckla. Like, I think if you look at this, you would reasonably conclude that's an incredible job of turning a Tesla Model 3 into a pickup truck. But at the end of the day, that's just not how you make a pickup truck. If you want to make a good truck, you have to start with the frame. The actual frame of the car can't be built for a sedan, it has to be built for a truck, or you're not going to get good results no matter how much engineering you put into it. In software, I think the equivalent is the stack that you build an application on. It's the starting point for everything that you build on top of it, and your software stack shapes the software and its capabilities the same way that the frame of a car shapes that car. And just like how if you start with a sedan and try to turn it into a truck, you get a bad truck, if you start with the wrong stack for your software, you're going to get bad software no matter how much effort you put into it. So I want to give you an example of this. And unfortunately, I think there might be at least one person here who has worked on this software, judging by the introductions channel, but I'm going to do it anyway. This is new Reddit. And I think everybody probably is aware of what new Reddit is. It's this new UI that they rolled out sometime in the mid-late 2010s for Reddit. And it's like universally hated by Redditors. And old Reddit is still online, which means that we can, to this day, still do this funny comparison of loading up the old UI and the new UI on the exact same site and comparing them. And old Reddit is like better at everything. It's incredibly strange. And like, new Reddit is notoriously just slow and bulky, and it doesn't really offer any advantages over old Reddit. So to give an example of this, like how much work do you think it should take to collapse a comment on Reddit? It's like hiding one thing and maybe adding something that says comment is collapsed, right? Well, I was profiling this in prep for the talk, and this is what it looks like. So like, there's all these events happening. There's this like superfluous layout in here that costs a bunch of time. There's all these other events happening, right? Like, this seems clearly excessive. I'm sorry, is that jQuery? What is jQuery doing in here? I'm sorry, everybody, this is actually old Reddit. Here's new Reddit. So this is what new Reddit does when you collapse a single comment. It's a staggering amount of work. Like it's actually unbelievable how much JavaScript is running when you collapse one thing. And like so I was timing this as well. So the old Reddit one, this flame graph here, this takes about 10 milliseconds on my computer, and that's not amazing, right? It should, in fact, I think, be like hiding a couple elements, inserting a couple elements. All of this stuff with events and dispatching, probably not super necessary, but 10 milliseconds for a one-off thing, not awful, right? It keeps you at like 60 FPS. Nobody really notices this as a problem. New Reddit, on the other hand, takes over 100 milliseconds to collapse a single comment. It is over 10 times slower than old Reddit at doing the same trivial task that was already done arguably too slowly on old Reddit. It's completely staggering. And like, how do we get here, right? What led to this? Are Reddit's devs just terrible? Are they lazy? Are they dumb? Are they just, JS framework fanboys who don't actually care about the end result and they just like want to, have all the fun of building Rube Goldberg machines in code instead of actually building good software? I think, that could be a factor, some part of it, but I really don't think it's the whole thing. I don't think that leads to this amount of waste. I think the bigger problem is the stack that new Reddit is built on, fundamentally. So what is that stack? Well, new Reddit is a React app. It's built with React and this state management library called Redux. That's, of course, on top of the entire web tech stack, HTML, CSS, JavaScript. That's all on top of some browser, which itself is on top of some operating system, and finally we get down to the actual CPU and memory of the computer that's doing the work. Now before I was at Mozilla, worked at a web dev company, like Adner mentioned, and our product used exactly this same stack. I think it was just pretty popular in the mid-2010s. So I'm actually pretty familiar with the way that an app like this is built, and when I was at that company, I actually spent a lot of time trying to improve the performance of that app. I was in the profiler all the time, looking for unnecessary computation, using the React dev tools to see which components were rendering, spot unnecessary ones, suppress unnecessary updates. We had this whole caching system, and I was adding automated like hit and miss tracking to the caches and making it log to the console whenever a cache was missing too much so that other devs at the company could spot these problems and fix them. Unfortunately, at the end of the day, I just couldn't really make the app very fast. When you're using this stack, you are constantly fighting the framework that it tries to generate so much unnecessary work, and then you're trying to suppress it all so that you're actually back to a reasonable speed. And this is nearly impossible as the app scales up. At the end of the day, I just had to conclude that it's not possible to build a fast application on top of this stack. Luckily, though, this is, of course, not the only way that you can make software. There's tons of other options. Really, for any point in this whole stack here, you can branch out into a bunch of different choices. So, for example, you could use a different JavaScript framework, right? There's Vue, there's Svelte, there's Solid.js, there's so many other options. And maybe some of these have learned from the mistakes of React and are way more efficient at doing these updates and renders and things. Or what's more likely a better choice, especially for the kind of example we're looking at, is to just not use any framework at all. Just use the APIs of the browser directly, or use a thin wrapper around it like jQuery or something, so that for something completely static like Reddit, you can just hide a thing, show a thing, done. You really don't need an entire UI framework being involved in all of this stuff. You can just do that tiny bit of extra dynamic stuff and be done. You could also branch out from the next level down. You could use different APIs within the browser. You could use WebGL and WebAssembly and do your own custom UI. And this might sound intimidating, but it's also something that a lot of companies are doing right now. Figma, for example, is well known for using WebGL and WebAssembly for all their UI. They've built up this whole custom UI stack for themselves, and the app runs really well. Like, even on pretty complex documents, it maintains a steady native frame rate on every device I tested it on. And one you might not know, Google Docs, Google Sheets, they don't use HTML, CSS for the actual UI of a document or a spreadsheet. That's all a canvas, and they're doing custom rendering for that because the typical browser stack is just too slow to do what they want to do. And of course, you don't have to build web apps, right? You can branch out from the browser here. You can use, if you want the cross-platform stuff, you've got other choices there. You could use Qt. It's pronounced cute, by the way. You could use a game engine, right? If you're going to do a lot of 3D stuff, or if you want to use their UI stack, right? Maybe that's an option. Or, of course, again, use none of that and just use what's available in the OS. These are all choices, valid choices for what you could build your software on. And different points in this whole tree will be better fits for certain kinds of software than others. So the thing is, I basically imagined that when the developers of new Reddit, when they were deciding what they were going to build this on, I feel like this is basically what they saw. There's not really a lot of choices here, and you'll notice that the best choice for them, which is what old Reddit did, is not even on the table, because I think that they just weren't actually comfortable using the browser APIs directly. They thought that was too difficult, or that there would be tons of benefits from this new stuff. The problem really that I see with this is that it's too high level. You can't actually access everything on this tree if you're stuck at a high level. If all you know is React, that's your choice. You can only build React apps or things that stack on top of React. But the lower level you can go, the more of this tree opens up to you. So in the short term, one of the main reasons that we care about low level in the handmade community is because the lower level you can go, the better choices you can make. The better software you can make just by starting in the right place, making a smarter decision right from the beginning, and therefore spending less time fighting the wrong stack. You can actually build trucks instead of trucklas. But also, this isn't really enough, right? This isn't going to fix the software industry if a few programmers are making somewhat better engineering decisions. This is not really the way to the future. It's an improvement, but it's not the answer. We have to contend with the question of what if there aren't actually any good options in this tree? What if none of these choices are actually good for the type of software we want to make? So for example, what if you want to make a native application because you need direct access to the graphics hardware or something like that, but you also want a cross-platform UI. You want to give the same experience on multiple platforms. What are your choices? They're basically what I listed down here, right? You can use Qt, but honestly, Qt feels really dated these days. It doesn't feel like a modern application. Plus, it's really opinionated about the way that you actually develop the software, so you kind of have to buy into this whole model of development that itself feels pretty dated and isn't really how people want to work. And game engines are obviously kind of a weird fit for a lot of applications. You don't really want that if you're building kind of 2D productivity software. And there's maybe some new options today coming on the market like Flutter, but Flutter makes you buy into Dart. And like, do you really think everybody should be using Dart for stuff? Like, people are going to want more choices than that. There really aren't any good choices here. So to reframe the graph here a little bit, collapse things down, the software industry basically looks like this to me today. Like, if you're just starting out with a new app, this is generally the picture that's available to you in terms of like the choices you could make to start. If this was a literal tree, it would look like this. And this is not a healthy tree, to be clear. It's really top heavy, and a bunch of branches are dying. It's not really a good, it's not a good situation, and it's not going to like get better. So the top heavy thing is like, there's so many JS frameworks, but like nothing down at the base, and it feels like it's going to collapse under its own weight. And the branches that are dying are like JavaScript frameworks dying out, right? I mean, what's the lifetime of a JS framework these days? I feel like the average is maybe like 2 years. It's like 5 if it's a good one. 20 minutes might be more accurate. So we need, and do we really imagine that this is what the future of the software industry is going to look like? Is it going to be incremental improvements here or more things piled on top? Do we really expect that in the future we're still going to be building complex applications on top of HTML and CSS, which are obviously not designed for doing complex UIs? Do we really imagine that we're going to be shipping apps on top of operating systems on top of operating systems? Because a browser basically just is an OS today. I don't think that's the future of the software industry. Clearly, we need new choices that branch out from lower in the tree. But who's going to do that? Who's actually going to develop this new low-level stuff of the future? It has to be a particular kind of person. It needs to be somebody who has this inherent passion and drive for like changing things about the software industry, for innovating. And they also have to have low-level knowledge. They have to understand the systems well enough to make different choices from those who came before and explore new parts of this tree that haven't been explored yet. And the overlap is so tiny here. There's so few people who actually fit into both categories that we're just not seeing a lot of innovation in that space. And this picture is pretty generous, to be honest, because there's just not that many low-level programmers, period, in the industry. So, for example, one of my coworkers at Mozilla, before he was at Mozilla on the SpiderMonkey team, he was at IBM working on their COBOL compiler. And thanks to be clear, he's not like some old graybeard. He's like the demographic of this conference here. But thanks to him and people like him, COBOL supports JSON now. Which, it's bizarre to me. And like, surely whatever future we imagine for the software industry does not involve JSON for COBOL. Right? No matter what ideas you have about how to improve, it is not this. Luckily, though, there are actually lots of people in the software industry with desire to innovate, to change things, to do programming better, to make good software, but they're all making JavaScript frameworks. Like, they don't have the low-level knowledge that they need to actually make a significant difference. That's just the reality of it. If you're building up way at the top of the tree, all the decisions have already been made for you. You're painting a truckla a different color. It is not going to make a difference. So the second big reason, then, that we care about low-level in the handmade community, and the reason that we think it can make for a better software industry, is that by teaching more people about low-level programming, we can capture some of those people who have that passion, that drive to innovate, and we can equip them with the knowledge that they need to actually innovate in meaningful ways. We need more people exploring that low-level space, and there are lots of people who want to, and I think that we can actually get a lot of them excited about low-level programming and like open their eyes to all these new possibilities that they had never even conceived of before, just because all they ever knew was the high level. And there's so many more choices the lower down you go. Like, not everybody who makes their own text editor is going to have great ideas about, programming environments and UI design and whatever other things. Not everybody who makes their own compiler is going to have great ideas about programming languages and programming models. But some of them will. And it doesn't take a lot of them to make a difference in the software industry. So, to recap so far, the first big reason that we care about low level is because low level knowledge can lead to better engineering choices. Better software just by making better decisions with the tools that are already available to us. And in the longer term, right, the bigger picture idea is that low level knowledge leads to better tools, better systems, that low level knowledge is a requirement for actually building this better future for the software industry. But there is one big problem that we still need to face with this. And this might be a tough pill to swallow for this audience, but I actually do believe that this is true. I think that low-level programming today is absolutely terrible. It is so frustrating and so difficult and just does not hold a candle to the high-level tools that people are using, that we see as the problem. Like, if I want to make a React app, I just Google how to make React app, and I will find an official website with a quick start guide that gives me like the high-level overview of all the concepts. It has interactive examples in the documentation. It has these paste this into your terminal and you'll have an app running on your computer in 5 minutes. Change one line of code in your editor, it immediately refreshes in your browser so that you've shortened that feedback loop and can experiment and learn more quickly. And then there are all these other resources, right? So many other tutorials that people have made, libraries that people have made, dev tools. There's like this whole world that is designed for the beginner that makes it so easy to get into. And this is just not the case for the low-level space, right? If you're lucky, maybe you get like an expensive course or a book or something that can teach you these things, but more likely you just get like a gigantic manual that lists in excruciating detail every property of the system or instruction of the processor or something like that. And this is not a way for somebody to learn, right? This is reference. And that's assuming it's even good reference. Sometimes you don't have a manual like this, you just have a wiki or a maze of man pages, and there's such an impenetrable wall of jargon that you can't even understand what they're talking about until you already understand the system that they're talking about. It's impossible to actually learn that way. And you might not even be as lucky as to have that. You might just have like the Linux kernel mailing list, and that's all you can go on for some types of low-level knowledge. And that's not just bad for beginners, that's bad for everybody, right? If that's the state of knowledge in the field, then it's not just that we can't expect people to learn, we can't expect anybody to like practice effectively in this field at all. And unfortunately, I think that's not even the end of the story, because I think low-level tools today are terrible too. Like in a browser, I can go to the dev tools, I can open up performance, I can click record, and I'll get this timeline view of every single thing that my application did while I was recording. It'll show me every single JavaScript function that was called, every single network request that was made, every single frame that got rendered, and it's all correlated on this timeline so that you can recognize problems, you can see what things are actually taking too long, figure out what triggered a particular strange event. It's like a developer's dream. These kinds of tools are so nice. And unfortunately, in the low-level space, like, we just don't have this kind of thing. Like, what do I do if I want this for native apps? And like, basically, all that's available to you is these like command line tools where you have to string together a bunch of flags and pipe that to other programs to extract the data, and then pipe that into other programs to make some kind of visualization, and then you're squinting at a PDF or something. And the crazy thing is that, like, is there some reason for this to be the case? Is there like more information available to the dev tools over here that allows them to give us these nice UIs that just doesn't exist in the low-level space. Like, it's the high-level tools, the dynamic scripting language that enables this kind of thing. Is that the situation? No, like, that stuff does exist. It's just that you have to know all of these command line tools and string together flags and all that. It's completely artificial. So, honestly, in this kind of environment, why should we expect anybody to learn low-level programming? How can we expect anybody to learn how to do low-level things? This is what I think was so special about Handmade Hero. Handmade Hero takes a subject that a lot of people find intimidating, that they see as incredibly complex, game engine development. And game engine development is one of those subjects where people think like, oh my God, those game engines are so crazy, they're so complicated, so advanced. You have to be like a super genius expert programmer to make a game engine. And if you want to make your own game, don't even touch that. You have to use an off-the-shelf engine. But Handmade Hero just doesn't care. It doesn't overload you with info. It doesn't have crazy prerequisites. Casey just sits you down, teaches you how to use a C compiler, puts pixels on your screen, and in like 10 or 20 episodes, you have a game. It's not the most incredible game in the world. The skill ceiling for game engine development is incredibly high, but the realization that people have when they go through Handmade Hero is typically, oh, this is not as hard as I thought. Like, I thought this was going to be super, super intimidating and difficult, and I actually have a game on my screen. This is crazy. I've actually found this to be true of every single low-level thing I've ever learned in my whole career. A lot of the time, things are hard to get into, but once I get in and understand them, I'm like, oh, that's pretty straightforward. In fact, the low-level stuff that I know is actually typically a lot simpler than the stuff I was doing at my web dev job before. Like, these high-level tools are actually so confusing and so complicated that it is harder to understand them than to understand these low-level things. But the high-level things, like your Symfony framework or your Kubernetes, like, they have docs. And the low-level stuff just doesn't, or at least it's not the same kind of thing. So low-level programming is just artificially difficult. It is terrible. I really believe that, but it doesn't have to be that way. So here's how I actually think about low-level versus high-level when it comes to programming. I don't actually think it's really about where something is in the stack, about how many layers it's built on top of. I believe that the only reason anything is considered low-level today is just that it's terrible to use. It's low-level because we don't use it directly. We have swept it under the rug, built stuff on top, so it becomes this low-level that we don't want to touch anymore. The reason that things are low-level is because nobody's made them high-level yet, but they could be. So when I imagine a better future for the software industry, I don't imagine one where everybody is making their own text editors or their own debuggers or their own hand-rolled UI frameworks instead of products for people to actually use. That's what they want to be building. So instead, I imagine one where we actually have new high-level tools that are built from lower in the stack that can give the same high-level benefits as the tools we expect today and more, because they're simpler, they have more capability, fewer of those constraining decisions have been made. They're not built on that towering pile of complexity anymore. We can build new tools that learn from the past tools, but that don't just stack on top of them. They come alongside them. So, for these kinds of tools, I think can actually make a huge difference for the software industry. For the developers who do care about making high-quality software, tools that are built down here instead of up in crazy JS land, they can actually give new capabilities to these developers, make it easier for them to do the job, like allow them to achieve the quality that they want. And honestly, for the developers who are just lazy or who need to get something out the door for whatever reason, tools like this, I think, can still produce better software than what the software industry is generally producing today. Even lazy apps can be more efficient and actually provide a better user experience at the end of the day. So, this then is what I think the Handmade community needs to do. Because within the Handmade community, we have people with low-level expertise. And we have people with this passion to change things about how software is made. So our job is not to just be low level and to sit down there forever and just, enjoy how cool we are for knowing how stuff works. Our job is to build a new high level for the rest of the software industry to use. Low-level programming is not the goal unto itself. High-level programming, a new kind of high-level programming, is the goal, and low-level is the way that we get there. Thank you.